Hello everyone and welcome to my lines and planes presentation. So before solving the question, I will identify some learning goals in this lesson. So the learning goals are identify and model points, lines and planes, identify collinear and coplanar, identify non-collinear and non-coplanar, identify the intersection of planes and lines in space. So here are some definitions. Collinear points are points that lies on the same line. Coplanar points are the points that lies on the same plane. Non-collinear points are points that do not lie on the same line. Non-coplanar points are points that do not lie on the same plane.
For solving the example, we have to figure out whether the three planes are intersecting or parallel. So we have to check the normals first to make sure that the three planes are not parallel. The normals can be identified as the number next to the letters. So the normal in the first plane is 1, 2, and 3. The normal in the second plane is 1, -1, and -3. The normal in the third plane is 2, 1, and 6. So there are two solutions whether the three planes are intersecting in a line or a point.
Now, after making sure that the three planes are not parallel, we have to make a test to see if the three planes are intersecting whether in a line or in a point. This test is called a triple scalar product. We take the three normals, take the cross product of two of them and the dot product of the third one. And if the answer is 0, then the point is coplanar, which means that the planes are intersecting in a line. But if the product is any non-zero value, then it's non-coplanar and the plane is intersecting at a single point. So now on to our next step. We have to test the triple scalar product on the example to see if it will intersect in a line or in a point. Quick recap for this part is if the triple scalar product give a zero value, it will intersect in a line. If it give a non-zero value, it will intersect in a point. So we will take the cross product of normals 2 and normals 3, so it will give -3, -12, and 3. Then we will find the dot product. So we write it as normal 1 is 1, 2, 3 dot, the cross product of normal 2 and 3, which is -3, -12, and 3. So it will give it -18. So -18 is a non-zero value, which means that the point is non-coplanar, which means that the planes are intersecting in a point, not in a line. So a quick review from the previous lessons about the triple scalar product is that the triple scalar product gives a volume of three-dimensional shape, and if the volume is any non-zero value, it will intersect in a unique point because the vectors are not falling in the same plane, which means that they are not parallel. So now onto our last step. We have to find the point of intersection. To find the point of intersection, we have to eliminate the three equations, find x and z, and then I will substitute the numbers into the equation to find y. So I'm going to number my equations as 1, 2, 3 to be easier. So the first step is I'm going to multiply equation 2 by number 2 to eliminate it in equation 1. So after multiplying equation 2 by 2, it gives me 2x minus 2y minus 6z minus 16 equals 0. I will name it equation 4. So my next step is take equation 1 and 4 and add them. So x plus 2y plus 3z equal -4 plus 2x minus 2y minus 6z equal 16. So it will eliminate y out of the equation, so we have x and z left to find them and then to substitute the numbers into the original equation to find y. So what I got is 3x minus 3z equal 12, and I will name it equation 5. The third step is I will add equation 2 and 3 to eliminate y also, because I eliminated in the first place, so I will keep doing that for the y. So equation 2 is x minus y minus 3z equal 8, and equation 3 is 2x plus y plus 6z equal minus 14. I will add them, it will give me 3x plus 3z equal negative 6. I will name it equation 6. So I will take now equation 5 and 6, which I did newly by eliminating the y, and add them to find the x. So 3x minus 3z equal 12 plus 3x plus 3z equal negative 6. So I will cancel the minus 3z with the 3z to find the x. So it's 6x equal 6. So x equals 6 divided 6, which is 1. Now step 5 is I'm going to substitute the 1 instead of x in equation 5 to find that z. So it will be 3 multiplied by 1, which is the x, minus 3z equal 12. So minus 3z equal 9. So that will be 9 divided by negative 3, which is negative 3. So the final step is finding y, and it's very simple because we are going to substitute 1 instead of x and minus 3 instead of z to find y from the original equation. So it will be 1 plus 2y plus 3 multiplied by negative 3 equal negative 4. So 2y equal minus 4 minus 1 plus 9. So 2y equal 4. So y equal 4 divided 2. So y equal 2. So now we found out the points. So the points is x equal 1, y equal 2, and z equal minus 3. These are the 3 points that the 3 planes are intersecting in. So that's pretty much it. Thank you, and I hope you like it. Thank you.